the second way to divide polynomials is something called synthetic division. And synthetic division is like this. The first step is to write the coefficients, meaning the numbers in front of the variables, of the dividend, so the degree is in descending order, meaning if it was x squared, that coefficient would come first. If it was x, that one would come next, and then your your coefficient at the end, the constant, would be at the end. Write the constant r of the divisor x minus r in a box. Okay, so for example, if I have x minus 3, in my box, I'm going to put 3. And we'll show you an example in just a moment. Step number 2 is to multiply the first coefficient by r and write the product under the second coefficient. Then we add the product of the second coefficient. And finally, we repeat these steps until we get a final number and there's no more numbers to multiply by. And that's going to be our remainder. Now this sounds a little confusing, but it's a little bit easier than it sounds. So we're going to take a look at example 4, which is using synthetic division to find what 2x to the third minus 13x squared plus 26x minus 24 divided by the binomial x minus 4. So the first thing was to write all of the coefficients of this one on a line. So I'm going to look at 2, negative 13, notice the minus sign becomes a negative, 26, and negative 24. So I read it like this, 2, negative 13, 26, negative 24. And then it said to put x minus r, that quantity r, so in our case x minus 4. 4 is going to be my r. And I put it in a box. And I put that right next to my coefficients. And I draw a line. Now what I'm going to do, I drop the 2 down right here. And now I multiply. 4 times 2 is going to be 8. And I add. Negative 13 plus 8 is a negative 5. Now I take 4 times negative 5, and I get negative 20. 26 plus negative 20 is going to be a positive 6. 4 times 6 is going to be a positive 24, and I have a remainder of 0. So that means, and this is the cool part, that means that if I'm dividing this whole thing right here, okay, 2x to the third minus 13x squared plus 26x minus 24 by x minus 4, what it ends up being is it's going to be 2x squared minus 5x plus 6. Notice this value right here went down by 1 unit, and then these answers right here are just the coefficients of my last thing. And finally, I have a remainder of 0. 2x squared minus 5x plus 6. Now I do this because I want to show you that it's the exact same as long division. So if I was going to do long division with this problem, I would put x minus 4 outside, and then inside I would have 2x to the third minus 13x squared plus 26x minus 24. And let's do the long division like we learned before. So, what do I multiply x by to turn it into 2x to the third? 2x squared. So I get 2x to the third minus. And 2x squared minus 4 would be minus 8 squared. And I subtract. So 2x to the third minus 2x to the third, 0 goes away. Negative 13 minus a negative 8 would be adding. So negative 13 plus 8x would be a negative 5x squared plus 26x. Now I say, what do I multiply x by to turn into negative 5x squared? That's a negative 5x. And so I get negative 5x squared, and then I get a positive from the x. And I subtract. Notice this becomes 0, and then I get 26 minus 20 would be 6x, minus 24 drops down. What do I multiply x by to turn into 6x? Well, that's a positive 6. So I get 6x minus, and then 24. And you'll notice there's going to be a remainder of 0. So the same thing happens. So if you look at them right here, notice my answer both ways is the exact same. It's just a different way of doing it. So here's a guided practice problem I'd like you to try 4a. Now the thing I want you to notice about 4a is this. Notice it's x plus 3. So we wanted to write it in the form of x minus r So my r is actually going to be negative 3. So what happens now is I'm going to put negative 3 in the box. And then I'll put my coefficients in. And I have 2, I have 3, I have negative 4, and I have 15. Okay, I drop my 2 down. 3 times negative 2 is negative 6. 3 plus negative 6 is negative 3. Negative 3 times negative 3 is 9. And I get a 5 here. 3 times negative 5 is negative 15. And I have 0 left over. So my solution is going to be 2x. Power goes down by 1, so the x squared minus 3x plus 5. There's my solution right there. Now, example 5 looks different. And the reason it does is because if you look right here, our divisor is not in the form x minus something. Instead, it's 3x. So I need to get x by itself. And so what I'm going to do is I'm going to divide this by 3. But if I divide my divisor by 3, I also have to divide everything here by 3. And so what I end up with is this. 3 divided by 3 is 1, so the x to the 4th minus 5 thirds x to the 3rd plus 1/3 x squared plus 7 thirds x. And then one thing I'm going to add here is plus 0. And the reason I add plus 0 is because I still have to have my constant term. No matter what I do, I have to make sure that I go in descending order and that the powers start at 4 and go down to 3, 2, 1, and then finally the power of 0 is my constant term. And then over here it's going to be divided by 3x divided by 3 is just x plus, and then 1 divided by 3 is 1/3. So I'm going to get a little sticky with some fractions, but it's okay because it's actually going to give us the correct answer in the end. Okay? So this is what I'm going to do. I'm going to do exactly like I did before. And I'm going to put negative 1/3 in the box. Now remember, we have to put a negative 1/3 because we want it in the term x minus r. So in our case, minus a negative would be the plus 1/3. Now, first coefficient is 1. Then I have a negative 5/3. Then I have a positive 1/3. I have a 7/3. And then I have a 0. And I'll solve it just like I did before. I drop my 1 down. Negative 1/3 times 1 is negative 1/3. And we can add these fractions easily. Okay, so negative 5/3 plus a negative 1/3 is a negative 6/3, which is negative 2. Negative 1/3 times a negative 2 is a positive 2/3. 1/3 plus 2/3 is 1. Negative 1/3 times 1 is a negative 1/3. And then I get 6/3, which is 2. And then I get a negative 2/3. I add it together, and my remainder is negative 2/3. Now that's where it kind of helps us out quite a bit. Now the reason I divided everything by 3 is because now these numbers down here are now the correct coefficients right here. If I hadn't have divided everything by 3, I would get numbers that were not divisible by 3, and it wouldn't work out correctly. So what I end up getting is x to the 3rd minus 2x squared plus 1x, I'm just going to put x, plus 2, and now this is my remainder, right? And so this is going to be minus 2/3 over x plus 1/3. And that truly is the answer, but x plus 1/3 is not what we originally had as our divisor. It was this, right? So I'm going to go back and I'm going to change it to this. And how I do that is by multiplying both the top and bottom of that by 3. And so when I multiply this by 3 and this whole thing by 3, it's kind of cool. What ends up happening is I get x squared minus 2x squared plus x plus 2, and then I get minus sign stays there, minus 2 over 3x plus 1. So check it out. This 2/3 now has become a 3 because I multiplied the top and bottom by 3. And so this right here is the final answer that I have when I use synthetic division. Here's a couple guided practice problems that you can try. Why don't we try 5C? Okay, so the first thing I notice right here is that I have to get rid of this 5. So I divide everything by 5, right? And so I rewrite it, and it's going to be 3b to the 3rd plus 8b minus 21 fifths b plus 6 fifths. And that's going to be divided by b minus 4 fifths, right? So now I can write this in synthetic division. Notice it's going to be x minus r. So in our case, b minus 4/3. So my r is going to be 4 fifths. And then I get 3. And I get 8 fifths. Negative 21 fifths. And then a positive 6 fifths. Okay, now I can synthetically divide. I drop 3 down. 4 fifths times 3 is going to be 12 fifths. So that would be 25th, which is 4. 4 fifths times 5 is 16 fifths. Negative 21 fifths plus 16 fifths is a negative 5 fifths, which is negative 1. 4 fifths times negative 1 is a negative 4 fifths. And then I'm left with 2 fifths left over. And so you'll notice that I have to multiply this by 5 and this by 5 in the end. And so what I end up getting is a remainder of 2 over, I guess I'm jumping ahead, I get 3b squared plus 4b minus 1, and then plus 2 over 5b minus 4. So right here is my solution when I divide those synthetically.